Okay, students, let's look at this problem. We are having a horizontal table over which there is a cart of capital M mass. Its mass is given as 0.5. It's 0.5 kilogram. Its mass is 0.5 kilogram, and there is a mass hanged over a string which is connected by a pulley over here, and the hanging masses of small m and small m is given as 0.2 kilogram. The cart is not initially at rest. It is moving in this direction with an initial velocity of 7 meter per second. We can take acceleration due to gravity as 9.8. These are the options. Let me read out the options. The acceleration is equal to 2g by 7 towards right. Option A is the acceleration is 2g by 7 towards right. Option B, the cart comes momentarily to rest after 2.5 seconds. The cart comes to momentarily rest after 2.5 seconds. Option C, the distance traveled by the cart in first 5 seconds is 17.5 meter. And option D, the speed of cart after 5 seconds will be same as initial. The speed of cart after 5 seconds will be same as initial. Let's solve this. In order to solve this, let's analyze over here. The smaller mass, it will experience a gravitational force of small mg. There will be a tension T over the string. That tension will cause a tension T over the string. And this system, it will accelerate downwards since it is a frictionless surface. If it's a frictionless surface, there is no opposing force to the tension. Therefore, the system will accelerate downwards, and if this smaller mass is accelerating downwards, this capital M mass will accelerate in this direction. Therefore, the acceleration over the cart will be towards right. Towards right is correct. Then we have to analyze, this is the acceleration 2g by 7. In order to find out the acceleration, let's formulate the free body diagram and the equation from this free body diagram. It will be net forces small ma, that should be equal to what, greater force minus smaller force, that is mg minus t. This is the free body diagram for the equation for the first free body diagram. And if we are formulating an equation from this diagram, free body diagram, we could say the net force is capital Ma, that is equal to T minus nothing, that is minus 0. U, it is velocity. Since it is velocity, there won't be any acceleration in this direction. Therefore, there won't be any force in this direction. That's the reason why we are writing T minus 0. Therefore, capital Ma is equal to T. Let this be our equation number 1 and this be our equation number 2. By adding these two equations, we could eliminate tension and we could say what? Capital M plus small m into A, that is equal to what? Mg. And from this, we could say A equal to small mg divided by capital M plus small m. Let's substitute the value. Small m is 0.2. 0.2 divided by capital M plus small m means 0.5 plus 0.2. 0.5 plus 0.2 is 0.7 into g. Therefore, it could be rewritten as 2 by 7g. Therefore, the acceleration is 2 by 7g. Therefore, the first option is correct. Then let's analyze the second option. The cart comes momentarily to rest after 2 seconds. Therefore, we have to find out the time in which the cart is coming to rest. The time in which the cart is coming to rest. Therefore, the cart is coming to rest means its final velocity will be 0. Therefore, we could use the formula V is equal to U plus AT in this situation. What is V? Since the cart is coming to rest means V is 0. Therefore, 0 is equal to U. What's U? U is 7 meter per second. U is 7 meter per second, but it is in the opposite direction of acceleration. You could see the acceleration is in this direction and the velocity, initial velocity, is in the opposite direction. And since conventionally this direction is velocity, this direction's velocity is taken as negative, therefore u is taken as negative. Therefore, I am writing minus 7 plus A. What's A? Since we have obtained it as 2 by 7g times t. Minus 7 taken to the other side, it will become 7 is equal to 2 by 7 gt. Then 7 is taken to another side, then it will become 7 sevens are 49. 49 is equal to 2g by t, that is t is equal to 49 divided by 2 into g. 2 into g is 2 into 9.8. Therefore, if you are simplifying this, we will get 2.5 second. That means the card will come to rest at a time of 2.5 second. Therefore, this second option is also correct. Let's analyze the next option. The next option is distance traveled by the cart in first 5 seconds is 17.5 meter. What they are saying is the distance traveled by this cart will in first 5 seconds it will be 17.5. Note that it is distance, it's not displacement. They are asking distance. Therefore, since we know at a time of 2.5 seconds it will come to rest. Therefore, until the first 2.0, in the first 2.5 seconds, the cart is traveling in this direction. The cart is traveling in the direction of the initial velocity. The cart is traveling in the direction of initial velocity. Therefore, let me find out that distance initially. That is, we are going to find out S1. S1 is the distance traveled by the cart in the direction of initial velocity. That is, in order to find out S1, the T1 value we could take it as 2.5 second. Then if we are using the third equation of motion, that is S is equal to ut plus half at square in this case, and we are substituting it, S1 is equal to, what is u? U, it is 7 and we are writing it as minus 7 into 2.5 plus half. A is, what is A? Is 2g by 7 into t square, that is 2.5 whole square. 2.5 whole square. Then if you are simplifying this, we will get minus 17.5 plus 8.75, and that is equal to what? Minus 8.75, and this minus sign is indicating that the displacement is in the direction of initial velocity, that is in this direction. Okay, that much meter. This is the displacement in the what? In the time interval of 2.5 seconds. Therefore, we are asked to find out 5 seconds time interval, then the remaining time interval is 2.5. Therefore, let's find out the S2 value, the next displacement at a time interval of 2.5 second. And in that time, that is, if it is traveling at a distance of minus 8.75 meter, at that instant the substance will be at rest. Why? It because 2.5 second the final velocity is 0. Therefore, in that instant the substance is rest. Therefore, in this situation we could say u is 0, then t is 2.5, then we could say s is equal to ut plus half at square, then s is equal to u is 0 means then s2, the second displacement, s2 is equal to half a. What's a? A is 2g by 7 into 2.5 square. Half into 2g by 7 into 2.5 square. We have already done it over here. Therefore, the answer will be 8.75 meter. And we are getting S2. We are getting S2 as plus 8.75 meter. Therefore, the distance traveled. They are asking you the distance traveled. Therefore, we have to take the modulus, that is minus 8.575 meter modulus plus 8.75, and we will get, yes, 17.5 meter. This is distance. But if they are asking you the displacement, we can say displacement will be minus 8.75 plus 8.75, that is equal to 0. That means the card will be at the same position. That means now we could say the option C is also correct. Then let's analyze the option D. The speed of cart after 5 seconds will be same as that of initial. This is the last option, and let's analyze that. We have to find out the speed of cart, that is V. We have to find out V after 5 seconds means we could use this situation. Then if we are using the situation, V equal to, we could use the relation V is equal to U plus AT. Then V is equal to, in the situation, U is 0 plus A is what? Is 2G by 7 into T. We could write 2.5. Why I am using 2.5? It is because in the second interval it is 2.5. That means we could say the total time is 5 seconds. Okay. Therefore, we will get 2 into 9.8 divided by 7 into 2.5. We will get the answer as, and that will be 7 itself, 7 meter per second. Therefore, we are getting 7 meter per second. That is, in the initial case, the velocity was in this direction, means in this case, since it is positive, means it is in the opposite direction, but it is asked speed of cart after 5 seconds will be same as that of initial. That is also correct. The velocity is having direction, speed is not having direction. Therefore, the option D is also correct. In this case, all options are correct.